Okay, question 1. The clue is not in the service name. The model must ensure its results are equitable and unbiased for all credit applicants. Which core dimension of responsible AI does this relate to? Select one answer. Review the answer choices on screen. The correct answer is option A. Equitable treatment of all applicants. That maps to fairness ensures equitable treatment of all applicants, preventing bias or discrimination in the model's decision-making process. What's up? Welcome to another Stack Lessons session. 10 questions ahead on responsible AI pillars, ML evaluation metrics, and SageMaker compliance tools. Read each one, use the 6-second timer, then check your answer against the reveal and the explanation. Take notes if it helps. Track your correct answers. You will want your score for the wrap-up. Okay, we're on question 2. To secure data used for training and inference in your AI models through encryption, which AWS service or feature should you use? Select one answer. Review the answer choices on screen. The correct answer is option C. Encryption lives in KMS, not IAM. Here's why. AWS Key Management Service, KMS, provides encryption capabilities for sensitive data, ensuring secure handling of training and inference data in AI applications. Here we go. Question 3. Wording first, memory second. The engineer wants to provide clear and understandable reasons for each decision made by the model. Which core dimension of responsible AI does this relate to? Select one answer. Review the answer choices on screen. The correct answer is option D. Clear, understandable reasons for decisions. That defines. Explainability ensures that the reasons behind the model's decisions are clear and understandable, helping users comprehend the model's reasoning process. Next up, question 4. Separate context from noise. A healthcare AI company, Detect AI, is developing a system to identify a rare disease from patient symptoms. It's crucial to identify as many actual cases of the disease as possible, even if it means some healthy patients are incorrectly flagged for further review. Which metric best reflects this priority? Select one answer. Review the answer choices on screen. The correct answer is option C. In rare disease detection, a missed case outweighs a false flag. Recall or sensitivity measures the proportion of actual positive cases, patients with the disease, that the model correctly identified. Prioritizing high recall is essential when the cost of missing a positive case, a false negative, is high, as in rare disease detection. This one trips people up. Let's see what the numbers actually reveal about these 4 metrics. Imagine Detect AI screens 1,000 patients. 50 actually have the disease. Their model catches 35 of those 50. 15 people go home undiagnosed. Now check the scoreboard. Accuracy is 94%. Specificity is 95%. Those bars look huge. Precision is 44%. But recall, the number that really matters is only 70%. Accuracy looks high because sick patients are rare in the pool. It tells you almost nothing about whether you found the sick ones. Recall is the only metric that asks the right question. How many sick people did we actually find? When missing a case costs a life, recall is the number that matters. Next up, let's look at question 5. Research Synth AI is developing a foundation model for scientific literature. The initial and most computationally intensive phase involves training the model on a vast and diverse corpus of scientific papers to learn general language patterns, scientific concepts, and relationships. What is this foundational training phase called? Select one answer. Review the answer choices on screen. The correct answer is option A. Massive corpus, first phase, general patterns, one term covers this. Pre-training is the initial phase in developing foundation models. It involves training a large model on a massive general dataset to learn broad patterns, language understanding, and world knowledge. This pre-trained model can then be adapted for specific tasks through fine-tuning. 5N, responsible AI has 4 named pillars. KMS owns encryption, not IAM. Recall targets the true positive catch rate. Next up, question 6. Avoid the familiar but wrong answer. An online marketplace is developing a model using Amazon SageMaker to predict the likelihood of a product being returned after purchase. The company has a labeled dataset containing product attributes, pricing, customer feedback, and return status stored in an Amazon S3 bucket. What machine learning approach is most suitable for this task? Select one answer. Review the answer choices on screen. The correct answer is option D. Labeled return status data points to one approach. Watch the distractors. Supervised learning is most suitable as the company has labeled data with known outcomes, return status. This approach can learn relationships between input features, product attributes, pricing, feedback, and the target variable, returns. Few-shot learning is for limited data scenarios. Transfer learning adapts pre-trained models, and unsupervised learning doesn't use labeled data. The presence of labeled data makes supervised learning ideal. Now, question 7 is up. When training a neural network, a data scientist at Neural Net Innovators is carefully adjusting a hyperparameter that controls the step size the model takes during optimization to minimize the loss function. If this value is too large, the model might overshoot the optimal solution. If too small, training might be very slow. What is this hyperparameter called? Select one answer. Review the answer choices on screen. The correct answer is option D. Step size and gradient descent has one canonical name. The learning rate is a crucial hyperparameter in training neural networks and other machine learning models. It determines the size of the steps taken during the optimization process, e.g., gradient descent, to find the weights that minimize the loss function. Time for another one. Question 8. Watch the tempting shortcut. A telecommunications company wants to forecast customer churn based on usage data. The company has limited machine learning expertise and prefers a user-friendly, no-code solution. Which solution would be the most suitable for this use case? Select one answer. Review the answer choices on screen. The correct answer is option A. No ML expertise, no code. Eliminate every option requiring coding. Amazon SageMaker Canvas provides a no-code visual interface that meets the company's needs. It enables building ML models without coding expertise through a drag-and-drop interface. Ground truth is for data labeling. Direct use of SageMaker algorithms needs coding skills, and personalized is for recommendation systems, not churn prediction. Time for another one. Question 9. Do not skim the condition. An AI developer is working on an AI-powered learning system with a foundational model to help students understand complex mathematical concepts. The system aims to provide accurate solutions and explain underlying principles clearly. The developer is exploring techniques to improve the model's performance. Which prompt engineering technique will most enhance the foundational model's ability to provide step-by-step explanations for complex mathematical concepts? Select one answer. Review the answer choices on screen. The correct answer is option C. Step-by-step mathematical reasoning maps to one specific technique. Chain of thought prompting is ideal as it breaks down complex concepts into sequential, logical steps, enabling clear mathematical explanations. Tree of thought organizes hierarchical relationships. Complexity-based adjusts to difficulty levels, and directional stimulus guides response focus but doesn't structure step-by-step explanations. This one has a sneaky distractor. Let's make sure you can spot it cold. Imagine a student staring at a quadratic equation. They don't need the AI to explore 5 solution paths at once. They need one clean walkthrough, step by step. Chain of thought prompting does exactly that. Just add "let's think step by step" to your prompt. The model then shows its work. Subtract 15 from both sides. Divide by 3. X equals 3. Tree of thought is the trap here. It branches into multiple reasoning paths and backtracks when stuck. Great for open-ended puzzles, not for a math tutor explaining each step to a student. The exam asks for step-by-step explanations. That's chain of thought. Full stop. Time for another one. Question 10. This is a distractor check. A security analytics firm is deploying an ML model to analyze network traffic for threat detection. The firm must provide comprehensive documentation of the model's development process and ensure its predictions are fully explainable for compliance audits. Which combination of Amazon SageMaker features will fulfill these requirements? Select 2 answers. Review the answer choices on screen. The correct answers are option A and option C. Documentation and explainability are separate concerns. 2 tools needed. 2 SageMaker features are essential for this requirement. 1. Model Cards provide structured documentation of model development, training, and deployment details needed for compliance audits. 2. Clarify offers tools for model explainability and bias detection, helping explain predictions for audit purposes. Ground Truth Plus is for data labeling. Smart Sifting filters training data, and Autopilot automates model building. None address documentation or explainability needs. Let's break down why this question needs 2 SageMaker features, not 1. Imagine a regulator walks into your office. They ask, "Why did your model flag this loan application as risky?" You need 2 things. First, a paper trail of how the model was built. Second, a clear explanation of why it made that specific call. Model Cards is the paper trail. It records your training data, evaluation results, and intended use. Clarify is the explainer. It shows which features pushed each prediction and flags bias. The other options handle data labeling or auto building. That's the trap. 3 distractors touch data, not compliance documentation or explainability. 3 takeaways from this session. First, fairness, explainability, transparency, and safety are distinct responsible AI pillars. Map each keyword to its own definition. Second, when missing a true positive costs more than a false alarm, optimize for recall over precision or accuracy. Third, SageMaker Model Cards documents the model lifecycle. Clarify explains its predictions. Compliance audits require both the recall versus precision flip and the Model Cards versus Clarify split are 2 distinctions worth writing down. They appear across every AI compliance question in this space. Before you leave, if this helped, hit subscribe so the next set finds you and so YouTube shares it wider. Tell me in the comments how you scored and where you struggled. Got a cert you want me to tackle next? Drop it below. And if anything about the pace or style could improve, that feedback genuinely matters to me.